In this video, we're going to solve a particular problem which appeared in JEE Advance 2017. In this problem, we need to test for the continuity for the given function fx equal to x into cos pi x plus greatest integer function of x, right, at the particular points, right? So let's go ahead and solve this problem now. So now, first, to solve this problem, first let us understood the problem, right? So here, a function is given and we need to test for continuity at different values of x, right? Where x is equal to minus 1, 1, 0, 2, and so on and so forth. So here, note that, right, that all the test of continuity point are integers, right? So now, here, if we test it, right, at each and every point, right, it will be much more complicated and we have to test for everything else, right? So that's why we just test it for at specific instead of specific point, we test it at a integer point, right? So that's why first we consider the point, consider the function, and then we test for the continuity at x equal to n, any arbitrary integer. So first, we need to calculate the left limit. So what is the left limit? We know the definition that left limit is we need to calculate limit x tends to n minus fx. So by the definition of that, we can easily convert it as limit h tends to 0 f n minus h. So therefore, we need to now find out what is f n minus h. To find out that, we need to substitute wherever we see x in the given function fx, right? We just replace by n minus h. Now, here we have to note one important stuff, that we need to find out that greatest integer function of n minus h. So that is the complication in this limit. So first we need to observe that what will be the value of greatest integer function of n minus h, right? So that we need to find out first. Let's go ahead. So here, to find out that, we just consider three consecutive integers. So the one integer is n minus 1, n, and n plus 1. So between all those values, right, we can see that n minus h, where h is greater than 0, must lies between n minus 1 to n. So therefore, the greatest integer function of n minus h will be definitely n minus 1. So that's why we replace that n minus h by the n minus 1. So therefore, we have it as, right, n minus h is equal to n minus 1. And then replace that in the respective position. We can see that n minus h and all that will be cancelled out. So that's why, right, our resultant limit will become n cos 2n minus 1 pi. Now we can say that why we can jump directly. Let's see that, right? So here, n and n, right, will be 2n and minus 1 as h tends to 0. So therefore, no term as h, right? So it will be gone off, right? Here also, it's n minus 1 h, so that will be left off. So therefore, we calculate the left limit for this particular case will be n into cos 2n minus 1 pi. Now, let's proceed. So therefore, it will be equal to minus n. Why? For any values of n, cos 2n minus 1 pi will be equal to minus 1, right? Because we know that cos n pi is equal to minus 1 whole to the power n. So that's using that, it will be minus 1 whole to the power 2n minus 1. That is minus 1 whole to the power an odd number. And therefore, it gives you minus 1. So that's why it will give minus n. Let's go proceed further. So now we need to test for the right limit. For the right limit, we just consider limit x tends to n plus fx, which will be definitely equal to limit h tends to 0 f n plus h. So if we go further in the similar notation, here we observe that n plus h box of that, or the greatest integer function of n plus h, will lies between n and n plus 1. So therefore, what will be the largest integer less than n plus h? That will be n. So here n plus h greatest function will be equal to n, and therefore our limit will become cos 2n pi. So n cos 2n pi became our right limit using the same logic, that cos 2n pi will be equal to minus 1 whole to the power 2n, which is an even number, hence it is n. So therefore, we find that at every integer point x equal to n, the left limit is minus n and right limit is equal to plus n. So therefore, we can observe that. And also if I try to calculate the function value at fn, right, we obtain it is equal to n cos 2n pi, and obviously that will be equal to n. So that's it. So now we need already find out the left limit, right limit, and the function value at that particular point. So let's go ahead. Therefore, from the left, right, and the function value at f equal to n, we understand that this all three values, the right limit, left limit, and function value, need to be equal only when n is equal to 0. Because otherwise, right, the minus n and plus n cannot be equal, right? So therefore, we can say that the given function will be continuous only when x equal to 0. But here, for this particular problem, we need to find out that how many points they are discontinuous, right? So that's why for this particular problem, option A, B, and D are the correct option. So basically, here we will conclude that every point, right, except x equal to 0, sorry, every integer point except x equal to 0, the given function is discontinuous, right? That's it. Now, let's solve that using some tricks as well. But here we solve it as left, right limit, and so on. Now, can we achieve that result, right, without computing all that stuff? Let's see that and put a glance on it. Now we already seen that option A, B, D are correct, right? Now let's try to understand that in a very second mode, right? Let's go ahead. So here notice that, right, that this function fx can be written as x into gx, where gx is equal to cos of pi x plus box x, or the greatest integer function. Now it is obvious that, right, that greatest integer function R is a continuous function except all the integer points. So that's why we consider it that it is discontinuous at every integer point. So here all the given points are there. So we can say that it's discontinuous at -1, 1, 0, 2. So all that point is discontinuous. Now, x is a continuous function, right? Y equal to x is a straight line. It's a continuous function. So therefore, x plus box of x is also discontinuous at this specific point only, right? Nothing much. Cos x is also a continuous function, right? So therefore, cos of pi of x plus x will be a discontinuous at only the specific point, right? That's obvious. Now here we need to test it at fx, right? So now we can understand that when we multiply by a value x, right, x gx we are talking about. So then for x equal to 0, whatever may be the value, right limit and left limit must be equal to 0, because 0 is act as a multiplier. So therefore, it is obvious that xgx, right, will be equal to 0 always. So therefore, it is discontinuous at -1, 1, and 2 itself. And that's it. So therefore, the correct option ABD, right? That's it. Now see that without solving the problem, right, or like right limit, left limit, we can achieve the final result in a second, at least in this particular form. And this is only because that we are having the cost function multiplier, because for cost function, right, it will lies between or bounded between -1 to +1, right? But suppose in some function, when we are talking about x into gx, if gx can have infinite values, right, so then we have to think little bit more carefully. Why? Because 0 into infinity, this is undefined, right? So but here cost value, right, cannot attain that in this particular case, infinite value. So therefore we can easily conclude this statement. Okay, so this is a trick. Hope you understood the problem. Thank you.